Welcome to Zen Live TV. You're watching the Alien Scientist Conspiracy, Science, and Controversies Hour. Views and opinions expressed on this program do not necessarily reflect the views of Zen Live TV, our hosts, our producers, or the guests we may have on from week to week. So just please remember that no one's gonna agree on everything. My goal is just to try to investigate phenomenon and investigate conspiracies or controversies in science out there and try to form an unbiased conclusion upon them, and always be open to new evidence and new information on all these subjects. And we like to have people input from week to week. Last week we did our podcast on Nikola Tesla, and this week I'm going to be doing sort of a part two, a continuation of that talk on Nikola Tesla and his contributions to the modern electrical system, his inventions, and different ideas about theoretical physics that he had and that he looked into, and sort of his legacy and the people that are really super Tesla followers and stuff, and also the idea of using his technology to build free energy and energy distribution systems that couldn't be that would be free, essentially, and talk about some ideas for things like that. Last week I had Ken Griggs on. He's a theoretical physicist and caller into the show, and he'll probably be joining us back here within the hour. And I also had a few other people who commented on the video from last week, and I asked some of them to call into the show as well to offer opinions and information regarding Nikola Tesla, because I know I have a lot of people in my audience who are very well read on everything related to Tesla, and probably some people that know even more than I do about Nikola Tesla. So I encourage those people to call into the show and share information or any ideas or anything that they want to say as well. I had a couple people leave some comments last week, some really interesting stuff that I was alerted to by some of my viewers that I had not known about. I'm going to give you a quick screen share. This was one link someone sent me to this Indiegogo campaign to build a planetary energy transmitter. Basically a giant Wardenclyffe tower to basically remake Wardenclyffe, or the idea of it. And I thought that this was an interesting campaign, seeing as they have pretty well laid out goals for everything that they're going to do. They've raised $47,000 so far, and these guys seem to be really open to new ideas and new information, and they seem to be open to a lot of the same ideas that Tesla had on how to build a planetary energy transmitter, so that you could basically transmit free energy to the entire planet, which would be wicked cool. So I don't know. I think this is an interesting idea. Not to say that it will work or that it's guaranteed success, but it's still an interesting thing. I'd like to. I wrote an email to these guys. I'm gonna try and get some of these people on the show to talk to them about some of these ideas in more detail. I know there's another group, Occupy Tesla, that I was have been posting a lot of stuff on Facebook and talking to a lot of people on there as well, who have a lot of the same ideas of using Tesla's visions of the technology that he was looking toward building, that before he was shut down really by JP Morgan, and lost a lot of his funding for a lot of his research and projects. There's a lot of people that want to think that they can crowdfund the research projects and sort of bring these things back and do more research in these areas that never really got done. Although there is a lot of research that probably has been done that I would think it would also be an equally good idea to sort of go after a lot of research that probably already has been done, especially by the Russians. There is these really big Russian Tesla coils that I had found pictures of, like back in 2009. I think I posted a video with some of the pictures in it. The sound unfortunately didn't come out for that video, so I had to replace it with an audio track. But let me see if I can't find this. It's not coming up with anything. Russian Tesla coils. Anyways, I don't have a picture of that ready. I was trying to find one real quick, but there was basically this research facility. I think in it's not Surrey, but it's another there's another high energy electrical research facility that was done. A lot of research was done there, and they had these really large Tesla coils. Yeah, here's the picture now. These really huge, just massive Tesla coils that they experimented with a lot of really high energy electrical technology, and here's one with even the coordinates to the place in Russia. Maybe it'd be worthwhile to go and try to find some of those scientists' research or the papers that they wrote on some of the research that they have as well, so that not as much time and funding is wasted for what they're going to be able to raise with this crowdsource campaign, in this Indiegogo campaign thing right here. So I think that this is an interesting opportunity. I think that these guys, they seem pretty credible from what I've read and what I've seen for what they have set up, and I think it would be really interesting to see their research come to fruition and actually build one of these things and show some experiments with it to see what it can actually do. But also in the last week's episode, I was basically talking about theoretical physics, the theoretical foundations of electromagnetism, or what's called electrodynamics, because magnetism is essentially it's electric force but moving. It's a dynamic result of the electric force and the electric fields. So it's really interesting that some of the theoretical physics that I was trying to really convey on last week's episode, that I think a lot of generally the people that are super into Tesla, some of them have really studied this stuff, and some of them know it really well. But for the most part, there's a lot of people that don't have a very solid understanding of this type of theory, which of course Tesla studied this stuff in order to get the foundations and the conceptual ideas to build his machines and be able to do the calculations that he did, and be able to. You need math in order to build electrical machines, the motors that he designed, all that kind of stuff. You need to know what kind of gauge wire you need, the thickness of it, based on what kind of voltages and currents you're going to be running through it. You need to know how many spins you need to make in each turn of the wire in a coil, so that you can know how to build transformers properly and get the ratios correct, and then be able to calculate how much current's going to flow through inductions from one coil to another, say, and other things. One of the most important things is the equation I have on the board behind me, which is when you throw time into it. This is basically RLC for RLC circuits. All kinds of circuits run on a similar differential equation like that, based on the capacitor, inductors, and resistors. And you can look up RLC circuits on Wikipedia or whatever. There's stuff in a lot of physics books about this that you can find if you want to really learn how this stuff works. It's interesting that it shows you the way that capacitors charge up and the way that inductors sort of charge up, using the capacitors with an electric field between two plates, and inductors by creating a magnetic field, which goes into itself. And it's sort of it's interesting, and that equation describes basically how those things function in time with time variable, whatever. You could make that not a zero. You could put like a function on there, like of a certain frequency or something, and then use that differential equation to find the resonances and different parts in a given circuit. So this is the theory that you will learn if you study physics in any college and today. And I still thought it was interesting that I got a few comments on that video of people, saying that, oh, you're a college-educated idiot, or that, like that some reason the science that I'm talking about here is wrong. The science that they teach in universities, that's somehow wrong according to these people. But yet I said science is only wrong if it disagrees with experiment. So that's the arbitrating factor. Of any two hypotheses, experiment will be the arbitrator of who's right and who's wrong. What agrees with nature? Go do a test in nature and actually see what nature tells you. Don't just have a guess and believe in something so strongly that you think that this is the way it has to be. Go out to nature and ask nature, and find different ways to ask nature. And one of the quotes I like is I think it's Erwin Schrödinger, and it was Heisenberg. He said this. what we see is not nature, but nature to our line of questioning. It's whatever questions we ask of nature, we can get like an answer back, and really, it's about going to experiment ultimately in order to find out what how this stuff actually works. And I think the stuff, from what I can tell, the stuff that they teach you in university, it works. You can calculate things and get real results, and you can use that kind of stuff to build real working circuits and motors and stuff. I don't think it would be very hard for you to build motors or electric circuits or any of this stuff if you don't have the tools needed to really calculate these things and understand time differentials and time varying functions. Well, that's with alternating currents. With DC, it's a little bit different. All these terms just drop to resistors and just basically become what's called a impedance. So impedance comes in different forms. It could be capacitance, inductance, or resistance. But it just so happens that in a time-varying dynamic alternating current, if alternating currents you get special results out of those based on these time differentials. And this is the math you need to understand that. I mean, it may look like gobbledygook, flute speak to people that don't know it, but that's what this math says. If you were to go and learn it and break it all down, I'm not going to do that on the show for risk of boring my entire audience and stuff. That can be done in your own time, and really is much more of a rigorous and disciplined thing that you can't really learn from watching videos. I get a lot of people that have been complaining about my videos being an hour long, and it's just I should go back to making the short condensed videos and stuff, and those are a lot harder to make. People don't understand like how much time it goes into making that kind of stuff. So really I convey enough information to people so that they can actually learn, oh, this stuff exists, this is what you are actually taught. So maybe you don't have the opportunity to go to college, or maybe you're in high school still and you want to learn what there is to know and what they're talking about. So I'm trying to sort of give people an introduction to these types of ideas and this information, so that they know where it is, where to find it when they're ready for it. And if they really want to understand how to build circuits and how to build electrical things and do things with electromagnetism like Tesla did, then these are the tools that you're going to have and have to use. These are the tools that Tesla used when and be sure he did lots of calculation. I mean, part of the reason Tesla was so successful and was this genius and such a great mind and such a contribution to modern electrical engineering and our power system and motors and generators and everything else is not because he studied ancient Hindu literature. It's not because he came from Serbia and had some sort of in-depth spiritual connection to some sacred knowledge or something. It had to do with his work ethic, and it had to do with the fact that he gave up everything in his life to really devote all of his time towards science and experiment and learning math and doing math and calculation and reading books. He was sick for a lot of his childhood, had like malaria and a couple other weird sicknesses that were going around in the 19th century, 1800s, and early 1900s. And so he had a lot of time that he spent in bed reading books and stuff. And but part of the reason he became so successful and was such a good electrical engineer and such a good inventor is because, well, one, he had a photographic sort of a three-dimensional realistic memory. He had basically the ability to envision things in vivid detail within his mind, and that combined with his extremely hard work ethic, because he used to literally spend all his time in the lab and that he found letters to his father after his father had passed away, written to him from his university professor, saying that Nikola Tesla works too hard. He's working too hard, and he's going to die of overwork. He's not spending any other time except for work. He's doing like calculation and schoolwork. I mean, that was part of the reason he became who he was. It wasn't that he had some secret knowledge that you're going to find in some book or some ancient literature, or you're going to find on the internet by watching a 5-minute video or even an hour-long video like this. You're not going to get you're not just going to magically become Nikola Tesla because you saw some secrets, or you knew a little bit about some secret that he knew, or read something that someone said, like the 369. You know, the secret lies in the three and the six and the nine. No, the secret lies in doing hours and hours of differential calculus and really drilling yourself to learn math and to learn science and to learn all this stuff, so that you can actually do calculation really quickly in your head and just see things and be able to build them the way Nikola Tesla could. Really, that was the secret to his genius. It wasn't. That was my sort of my argument in last week's episode. I'll continue. I wanted to sort of elaborate on that because it really didn't get enough time to really delve into the whole Nikola. I mean, it's such a complex issue, and there's so many different things that have been written and in the history of that man's life. So it's I definitely wanted to do a part two today to really do that justice. But anyways, that's basically what I have to say, is that it was to do with Nikola Tesla's work ethic and the fact that he's put all his time into learning everything that he could at the time about electromagnetic theory, which of course I explained in my last video that Tesla did not contribute a heck of a lot to theory. He wasn't a theoretical physicist. He was an electrical engineer. He took theory and applied it and built things that worked, that really worked and did things. You know, that was sort of, and he did it because he spent all of his time in the lab. Another thing, Tesla, he was completely abstinent. He never had a girlfriend, never had sex in his life, ever. He was just spent all his time working in the lab, and he refused women's advances. He even had like girls hitting on him and stuff. But he just would rather spend all his time in his lab doing research and doing work, and sort of was just, his passion was for building things and experimenting, and his inquisitive nature, you know, of what the universe is really doing, and how to you know, basically manipulate the natural ways that the natural flows of the electromagnetic fields into actually doing things for you, building circuits that can do calculations that you can build calculators out of, or iPhones, or all the stuff that we have now today. The fact that your iPhone works on a frequency that sends a pulsed message out that is then picked up by the cell tower and translated back and forth in real time. It's all based on these laws of electrodynamics and also quantum mechanics to a good extent. And really, I just encourage people to, you know, you maybe call me a college-educated idiot, or say that, you know, I'm so sure of myself. I'm just an undergraduate, but I'm talking about graduate level physics as if I really understand things. I mean, honestly, you have never gone and studied the math and looked at it. So how can you say it's wrong, or that it doesn't describe science, when it gives you real numbers and real calculations that you can use to build stuff? And I mean, this is how Nikola Tesla built everything that he ever built. It was through hard work and a lot of time invested in the maths and sciences. So really, people, I think, are deluding themselves to a certain extent out there, thinking that they're going to get all this sort of sacred knowledge just by reading Hindu scriptures, or a couple things that people wrote about Nikola Tesla, that's going to give them the secret back door into understanding, you know, into Tesla's knowledge of how, you know, he was able to take these ideas, the concepts from theory, and sort of envision them in his head about how to build real things and do real things in the real world with using power, using electrical power, different sources of energy and being able to harness them and convert them into electrical power, like hydroelectric dams at Niagara Falls and whatnot. So anyways, I wanted to talk a bit. We're getting almost to, we got 10 minutes until we go to break. In the second half, when we come back, I really want to get into the worldwide dynamo and some of the science behind the Wardenclyffe Tower. And you know, Tesla had this thing set up, and they basically put all these light bulbs out in the field, and they all lit up on their own power, just the ambient power that was being transmitted through the air. And you could stand in that field, you wouldn't feel anything, but the power is going right through your body, through everything else. But I thought it was, some of the stuff that he thought of and envisioned was so ahead of its time that it really like boggled people's minds. They just didn't understand like how this stuff could work. But again, it's all based on just his understanding of electrodynamics. And you set up this static electric field, and you can literally tap into that with different, if you build the power receptors around it and different ways to tap into it. And so anyways, I'm waiting for Ken to call in. He said he'd be calling in by now, or some of the other people that said they would call in to this week's show. Hopefully have some questions and stuff, because but anyways, I definitely think that a lot of the people out there that were just, oh, here he is right now.
Monday's got you off the wagon? Well, worry no more, because it's now officially a part of the 3-day weekend. So get on board. Come party with the Standby Gypsy, Juju the Model, and Blue Rivera every Monday night.
I was explaining how when he came back from university at Graz or whatever, he found these letters after his dad died that his professor had written to his father, basically saying that he was working too hard and they thought he was going to overwork himself and die of overwork. So it's really people have this sort of notion that they're going to get all this secret knowledge of Nikola Tesla by reading ancient scriptures or by tapping into these weird esoteric things. But it's really like they're missing a lot of the big picture, that he spent a lot of his time invested in hard work, and his sort of genius came out of taking that theory and then applying it to build things in the real world. And actually build physical things. So his ability to also envision those within his head and know how, see all these wires in 3 dimensions and know that how the current's going to go through, and then also thinking about it in 4 dimensions, because he's thinking about it in time with alternating currents, with the current flipping back and forth over time, with other things rotating. Like you have the commutators that he built and stuff like. And his whole thing, we got rid of the commutator in the motor altogether, because all the motors up until that point had brushes, and he was the first person to envision how to build a brushless motor. And sort of he describes in his autobiography that he got that as like a spark of genius that just sort of like appeared in his brain and came to him all of a sudden. But he really had thought about that problem and worked on it for a really long period of time up until that. So he probably had all the pieces around him, knowing how time variant changing electromagnetic fields work, and then being able to apply that and into a way to get rid of that, so that he knows that, all right, well, you have a current going through this coil, it's going to set up a magnetic field which is going to induce a current in the other coil, and then figure out a way from there of how to get things to match and work right in 3 dimensions. Because like I worked on anyone ever tried to build a motor? I mean, like you ever tried to because the motor starts accelerating, it starts going faster and faster, so you can't just have a timed pulse delay like one that speeds up. It has to be synced with the rotation of the motor, so that you pulse it right at the right times when it's,
that's right,
and it's not easy to figure out how to do those sorts of things without like things like brushes or and stuff. But anyways, Tesla figured it out, and I think that he did a lot of that through his just genuine hard work. And you know, calling me a college-educated idiot because I believe in the almighty laws of mathematics and science. I mean, like some of the comments we got from last week's, it's like there's people out there that are super diehard Tesla fans, and they sort of have enthroned him on this shrine of almighty holiness, and
Right, and
I,
that's sorry.
which I think is, you know, I mean, he was a pretty awesome guy, but I mean, I
No,
don't know about
Tesla.
calling him a god. I'm gonna
Right,
switch
okay,
over to
so
my headphones so I don't get any feedback.
that's all right.
But
So
anyways,
Tesla was a man, and you know it seems like a very simple statement, but the idea is that every great person in our society has gone through a lot in order to invent or do the wonderful things that they've done. I mean, that's just the general scope of things. Sir Isaac Newton would have been considered, a genius on every level except for his actual personal life. And the same thing with Leonardo da Vinci, the same thing with, I mean, the list goes on, Mozart. So from time to time, it seems that there's enough information in what's going on in that current time span for someone to be able, like Tesla, to pull that information together. He did have a genius about him, obviously. His imagination, his hard work, all of that led to the greatness that he was able to create. But he really was the right man at the right time. And
right.
and you know the whole notion of creating a godlike figure out of him removes our need to really try to understand what he did. Okay,
Or
and
the,
that's not very helpful to us as a human species. This is
or,
one of the
or
very
us, our
yeah.
viewers as scientists or engineers out there who are trying to replicate his work or trying to, you know,
That's
build Tesla coils or
that's
build worldwide energy transmitters and stuff.
that's right. I mean, and some of the things that we've learned about him from his writings and from other people's research or interviews at the time, and certainly from the research that's come about because of the stuff that he's done. Some of those things are still earth shattering. Some of the ideas we are kind of probing now in physics. For example, vortices, etc. These topological structures that look like vortices that have a mathematics about them that might actually explain quarks. But
Right.
and actually is behind loop quantum gravity. But so there were
Ooh.
some very interesting ideas that he was, you know, on top playing with, whirling around in his mind. But honestly speaking, if you spoke to a lot of the physicists and the mathematicians at the time, they were all going through that. I mean,
Yeah.
not everybody coming up with the same ideas, obviously, but many of them were exploring these unbelievably different ways of describing physical nature. And that's one of the things that we also have to really gain from this. Tesla.
We're gonna have to hold that thought because we gotta go to commercial break right now. We are at the 4:30 mark, so let's roll commercial and then we'll come right back to that.
Monday's got you off the wagon? Well, worry no more, because it's now officially a part of the 3-day weekend. So get on board. Come party with the Standby Gypsy, Juju the Model, and Blue Rivera every Monday night for your entertainment week in review. Off-the-wall interactive segments, live performances, in-depth interviews, and the latest in sports. The Hangover Takeover is live every Monday night at 9 p.m. Eastern Standard Time, only on zenlive.tv.
So what we're gonna do is just to obviously since we're not taking to go to court. I mean he has no case, but it would really cost us money to go to court. You know, so we're just not doing that. We're just doing this whole 6-show bullshit.
Right.
But I'm letting you know though, when he comes, I mean I'm closing that door.
He's in and out. Yeah, that's it.
Yeah,
No,
like,
everybody sent me the text message. He was like, look, man, 6 sharp. Fuck out of here. I don't want him here past 7:01. He has get it. I mean,
I'm not
definitely
even
with
gonna
it.
be. I won't be.
I don't blame you, but just how am I gonna open the door?
Oh no, no, the door. I'll open the door. A couple minutes.
And we're back.
And we are back. We're talking about Nikola Tesla as a continuation from last week's discussion on the secret physics knowledge of Nikola Tesla and sort of what he knew about the universe that allowed him to invent what he did and do what he did in his lifetime. And sort of we were talking about just the times of when he lived. Right after Maxwell had sort of put together all of Faraday's work and discoveries with electrodynamics, that the electric field and magnetism were both very deeply, intimately connected, and that there were a mathematical nature of the universe based on time differentials of moving electric charges, electrodynamics, that creates magnetism. That magnetism is electrodynamic fields. It's just an extension, a relativistic extension, if you will, of the electric fields, but back to sort of, these insights that Nikola Tesla had into these things like vortices and trapped electric fields, things spinning in a circle, which sort of has led to, and nowadays where you were talking about a lot of the quark theory and theories of what matter is. There's a lot of interesting things that he was sort of onto back in in that day, that they were looking at things like pair production and pair annihilation. This is a really very interesting phenomenon. When I first heard about this in physics, I was like, "This is real." Pair production and pair annihilation is when you have two particles, like a proton and an antiproton, a electron and a positron, right?
Exactly.
And the electron and the positron,
or a proton and an antiproton. Those two
that can work too. That can work too. But it's basically a particle and its antiparticle pair, and they do this.
Right.
They do the spiraling dance of death, and then when they collide, they both all the mass goes bye-bye, and it turns into two gamma rays that shoot out perpendicular to the axial of that rotation of that dance of death. It's kind of like this weird thing happens. These particles spin around each other, and then they annihilate each other, and then they turn into two photons. So the mass just disappears, and then it also can, I believe, if an incoming gamma ray strikes a neutron inside a nucleus, you can have pair production.
Or brushes right by it, right? Mm-hmm.
Or brushes right by it. What can happen is it disturbs those fields, and somehow out of those fields create these vortices which become particles. They become the positron and an electron.
That's right.
So
they become matter and antimatter. That's right. Usually an electron and a positron. Mm-hmm.
And sort of that's based on this whole theory of the universe, that the universe was created out of this Big Bang, which created all these ripples and vortices, which of course the particles that we as we observe them are really, in fact, just trapped electromagnetic fields, which is interesting because if you look at Einstein's relation for matter, E equals mc squared, it has mass in there. It says that the energy of mass is related to the speed of light squared, which is basically pi r squared is the speed of going in a circle. So if you take the speed of light being r and make that go in a circle, it's sort of like you're having trapped light going in a circle at the speed of light, that it's trapped at this point, and that's what mass is. And it's energy that's trapped at this going in a circle at the speed of light, sort of.
Trapped energy, bound energy. My own research comes across the idea that that matter comes about because information is running in loops or cycles, and that constitutes what we would normally call inertia, or what we would normally also call the spin of that particle. Those two things are intrinsically linked. But yeah, these vortices, these whirling concepts in the electric field are exactly what they were probing at that time. That's how Tesla came into it, it seems. He may have come up with that on his own, but there were other people who were asking the same sorts of questions. And we've been asking those questions right on through. Some of our greatest physicists, I'm trying to think, it wasn't Freeman, no, it was Freeman Dyson. And then very recently, in the 1970s, actually 1980, someone wrote a book on the idea of these vortices actually appearing inside inside nuclear particles. In other words, something like the quark, and those vortices have certain spin predilections. Okay, so when you have a vortex and you have another vortex that brushes by it, there's a certain way that the other vortex sort of brushes by. But the whole point is that this phenomenon is measurable, and this measurable phenomenon actually agrees with experiment. So it becomes one of those, it was one of the questions in quark theory, why are the quarks behaving like this? Now, we believe today that it's because the quarks have intrinsic spin. But in the end, this whole idea of vortices is still wrapped up in trying to explain modern physics. We're still exploring it. And again, loop quantum gravity is a great example of
Well,
that.
it might not just be a like a tornado or a regular vortex,
Right.
like in
That's
a on like a the drain, the water going down the drain.
Thank you for clarifying.
We actually think about that the vortex loops around on itself and creates knots.
That's right.
Three-dimensional knots in space, and there's a lot of physics that's being done with knot theory and also just what's called topology, the connectedness.
Yeah, exactly. The topology, which is basically how many holes are there in your space, but with the topology that looks like a vortex, right? So whatever word you want to apply to it, there is underlying math to it, and that underlying math, at his time wasn't really available. We've only begun to really create this new, for example, the Wilson loop, which is the core mathematical feature of loop quantum gravity. That structure was created in like the 1990s.
Yeah.
Okay, so he didn't have access to it.
It was 100 years after Tesla was making electromagnetic, radio-controlled boats. He made a radio-controlled boat at the 1893 World's Fair, and it was like people were just like, how could this be? I mean, it just blew people's minds at the time that he was like, okay, well, what I can do is I can have a variable different frequencies, and I can have this thing pick up. So if I shoot this frequency at it, it does this action. If I shoot this frequency at it, it does this action. And all you need is 4 frequencies really for a boat, because you just have the power, the throttle to the boat, and then left or right. I mean, it's really not that hard, but he was able to think about it and vision it in his head and be like, oh, okay, we can do this. I'll build a little thing that transmits at these frequencies, and when it picks that up, it will do this, and picks that up, it will do that. And then you it's about understanding sort of these basic core concepts and then applying them to real world situations. And engineers do that every single day all over the planet.
Every day.
And they wouldn't be able to do it without math. Otherwise, it would just be guesswork. I'd be like, well, I think, let's go with 50,000 gallons. Okay. That sounds about right.
And one of there's another physicist named Nima Arkani, I believe. But Nima's perspective, he's really big up in the superstring world, but Nima's perspective is that, and I agree with him, that's why I'm mentioning it, but it's the idea that the physics that we keep learning makes it more difficult to come up with new theories of physics, because we have to encompass all of this physics that we know works before. So when we come up with electromagnetism because of Maxwell, we have to encompass what Newton's ideas were before. So it's not a free-for-all. And when we come up with relativity theory, we have to encompass electromagnetism, Einstein's gravity, and all of the other mechanics that come before. And when we come up with quarks and quantum chromodynamics and quantum electrodynamics, we have to encompass all of these mathematical regimes that have come before.
That's one of the things that we talked about in my past episode, that I don't think that trying to build a theory that encompasses all those things, I don't think they're ever going to do it, because it could be a generating function that creates the universe that all those things fall out of as a result.
Well, no, and you're right. And that's exactly right as well. So the idea is, how do you, instead of necessarily putting a blanket over all of these past ideas, right, and saying that how they came in is exactly the way they have to be, maybe the idea is that relativity is a statistical phenomenon. And that's not how Einstein came up with relativity theory, but maybe from our perspective, the language that we can use today, we can simplify it. We can come up with exactly the formula for relativity theory, but simply as a macroscopic statistical phenomenon like thermodynamics. So I mean, it's just that kind of.
But that always bothered me about thermodynamics was that it's all statistical mechanics. That there wasn't like we're not learning like the real physics of how this heat flows or this energy. You're just kind of doing the statistical dynamics and modeling and stuff, and it works. It gets right answers and it explains. It gives you predictions that agree with experiment, but I was just never happy with that.
Hey, look, I didn't like StatMech myself either, so I did. But one of the things that we appreciate, right, is that since there are an Avogadro's number, 10 to the 23rd molecules per mole of gas or whatever the chemistry was, but
it's
this unbelievable number of things that it provides a nice way of getting to those unbelievably large numbers. But you're right, we still have to understand what are the mechanics at the particle level, right? So we still have to know chemistry. We still have to know why the hydrogen atom. Yeah.
What is heat? What is temperature?
Yeah, precisely. What are those actual things at what we call a micro-canonical level?
What is energy?
What is energy? Exactly.
That's one of the biggest questions in physics.
It still is. And certainly, maybe you don't know this, but my research basically says, par excellence, if you want to use that sort of terminology, that energy is information. And that's one of the things that we are beginning to really learn and assess, that the movie The Matrix wasn't it was a brilliant movie. It wasn't as wrong as we might want to believe that it was. That really, and this is where a lot of these various programs, loop quantum gravity, super gravity, super string theory, all of those things are seemingly headed into that way of thinking, that it seems like energy is what we call information. Shannon sort of codified information in the 1940s or whatever, and because of that codification, your telephone company, or at least used to, can bill you for how much information is running through the lines.
Wow.
So thank you, Shannon, right? But Shannon's information allows us to then look at energy in terms of information content, and the whole notion of entropy and all of that stuff. So the idea is that these cycles or these loops or these Wilson loops and loop quantum gravity really might just be packages of information. And in this sort of more modern perspective, then we get to ask some deeper questions, like the Matrix movie questions. Do we live on a computer, for example, if information is a loop in loop quantum gravity? And if that's so, what is the program? What programs are running on this, universal computer?
Right.
But these are the modern perspectives.
Are we in some like super type 3 mainframe or something like?
Precisely. Precisely. Yeah, exactly.
Entire universe could exist inside of a simulator.
You got it.
Running on some alien's computer.
That's right. Some 10-year-old alien kid who's like, I'm gonna have fun today.
Yeah.
I want to play this video game.
I'm gonna keep changing the laws of physics ever so slightly. Yeah.
That's right. That's right. And let's see if the jokers can catch up to us. All right. But in the end, we seem to be landlocked onto this information superhighway. And certainly one of the questions will be, can we get out of it? Is matter information? Are the laws of physics actually changeable? If it is, and if not, why? Okay. And if you were programming this computer, would you make the laws of physics difficult, or would you make them as easy as you possibly could? And from our own abilities with algorithms and programming, look, we're using the binary system, so we're really trying to make it as simple as possible, right? So we want to at least begin to see that physics really has that same simplicity. And again, thank you, Shannon, for introducing us to the idea that possibly energy and information are one and the same entity.
And Shannon is C-H-A? Or
S-H-A-N-N-O-N or N-N-A-N, something like that. But cloud I think it was
Cloud
Cloud.
chain, yeah.
Yeah.
Well, people can look it up. I'll post a link to that in the description after the show. So,
Okay,
anyways,
he worked with Bell
another.
Labs. Mhm.
Oh, sorry. Another viewer from last week posted a link to that this Indiegogo campaign to build a planetary energy transmitter. I don't know if you checked that out. Did you? Uh,
No, actually, I didn't have a chance to.
well, I thought it was interesting. They've raised $47,000 so far, and they want to try and rebuild the Wardenclyffe Tower type idea,
That would be fantastic.
and do some experiments with that. I thought it was a really cool thing, and I didn't know if you had checked it out. I wanted to hear if you
No,
had any thoughts on it, but if you haven't checked it
but
out,
I have some upfront thoughts, which is that's fantastic. Anytime you want to check it out yourself, you want to build it, you want to see if it
Yes.
works, that's what you have to do. That's what science is all about. Okay? If I can, sort of the universality of science is that if he could do it and he gave you the plans, or you have some semblance of the plans, you should be able to do it too.
right?
Okay.
Well, even the concept, the theoretical idea behind these telluric currents and sending power through the Earth and or
That's
sending
right.
power through the atmosphere just through air. There's a lot of physics that are well understood nowadays, perhaps more so than they were understood back in Tesla's time, that could be used in the hands of the right people to really revisit and rebuild a lot of his ideas.
That's
And
right.
prove it experimentally. That's what they're determined to do. That's what they say right in their thing. And I think
That's
I said
fantastic.
this is great. This is what more people need to be doing.
Absolutely.
Going to
No,
experiments and
absolutely.
stuff.
In fact, this is what we were doing in the 1960s. People in their backyard garages and whatnot, they were in there building their own radios. So we aren't dumb, okay? We can get out there, we can do it, we can have our own engineering labs and try to set some of this stuff up. Tesla told you how to build a Tesla coil. You can build it. A lot, yeah, I completely agree. Go out there. If you think it should work, prove it. And the proof is just build it.
Build it
Okay,
and
now if
try
you
it.
need more money, hey, yeah,
Yeah, if you need more money, Indiegogo, this crowdfunding idea is great. I mean, this is such an awesome opportunity to really you know, find out what Tesla really knew and what kind of things he was onto and
that's right.
but also I was pointing out that a lot of research has already been done with high energy Tesla coils and other stuff.
Yes.
There's that I forget what it's called. I remember I found these pictures of these Russian Tesla coils, right? And
Uh-huh.
this big facility that's somewhere in Russia. And I remember I ended up figuring out that it belonged to. If you look it up on the map, it's in the wilderness outside some Russian town where there's this technical university. It's like one of the institutes of technology over in Russia, and apparently they had built these things to do a bunch of research. And I don't know if it was originally connected with military or other things, building big giant weaponized Tesla coil towers to like zap tanks or incoming jets or whatever have you.
Right.
But a lot of this research has probably been done at some of these universities, and it might be worthwhile to try and back catalog some of that kind of stuff. I mean, the size of these towers, they're like they're taller than the tree, at least twice as tall as the tallest trees around there. And I don't know if I have to show you send you a link to see the pictures on these things, but really the kind of funding you have to raise from an Indiegogo campaign just to build those types of things, they're already built here in Russia. Maybe you guys could take a field trip over there and use their Tesla coils. That way you could just do a lot of the experiments and publish the data online. With they got the generators out here. They're called Marx generators, is what they're called.
Okay.
MARX. I guess he was a Russian engineer or physicist who came up with the same idea. It's just basically like a scaled up Tesla coil, and these things get up to tens of millions of volts, maybe even hundreds of millions of volts, and they do some really interesting experiments with these things, and they have the infrastructure and everything built there to do the experiments. So I don't know. They're a Tesla coil anyway. It's a little bit different than Wardenclyffe Tower, but really not that much. honestly, the Wardenclyffe Tower was just basically like a giant Tesla coil at the top that would charge up to these super high voltages, and then the voltage would go through the air that you could tap into that electric fields that are going through the air. That's basically how it would transmit energy through the air.
Got it.
So it's the same basic idea. They already have these giant ones built. I mean, why you have to raise? They're talking about raising $800,000 to build it, like some of these things that you'd have the kind of money you'd have to raise for these types of large level construction projects, and the infrastructure is already here at this university. I mean, like you could easily maybe contact the head of research there and send some letters of inquiry. I might even. I'm hoping to send this video to those guys over at the Indiegogo campaign and let them know about this facility. I gotta figure out where it was again. I had all this information like a couple of years ago when I first was looking into it, but it's been so long I'd have to go and find it again. But yeah, they have these giant Tesla coils built here at this facility in Russia. I got the pictures of them here.
Yeah, I got some pictures here as well. Wow.
Yeah, you look
nice.
up.
Now, I was just going to say, even though Russia's having its current political problems, we're still in the science communities fairly well paired with our Russian cousins. In other words, there are a lot of exchange programs where they're certainly willing to work with us. I mean, for God's sake, we're launching into space because of Russian rockets. So don't think of Putin and the Crimea as your problem for not engaging Russia with some of its academic research. In fact, my advisor, yeah.
It's like you're contacting a professor at this university who's probably spent the last few years studying this exact thing, and you're not calling him to talk about Crimea or to talk about the political climate in Russia or his opinion on Putin. You're asking him for collaboration and research and information, and a lot of the experiments and the time and effort that these guys are putting in that they'd want to do, that information might already exist inside research papers that were written at this university, and all you'd have to do is find a way to get them or contact someone there who knows where to find them and can get them translated to English for you. And
Precisely.
This is how to go about finding information and doing these types of things, and also sharing that research. I mean, the amount of time and money that they've spent you could save, or even if you have experiments of your own that you'd like to do with like super high energy transformers and the experiments that they want to do, they have the facilities here. I mean, these towers probably cost at least $1 million to build all of them if you look at how many there are and how big this facility was. You don't have to spend that money again. It's already there. I'm sure. I don't know how well, if these things are in disrepair or whatnot, but maybe you can get the money to fund an Indiegogo campaign to fix them up and get them working again and do experiments with them. I mean, but anyways, that was my whole thing about the Wardenclyffe Tower and Tesla's idea for a global worldwide dynamo, as he talked about in a couple of the publications that he or his writings anyways. So I think, yeah, this is great that people are doing these types of experiments, and I want to see more into this stuff. But hey, don't just call me a college-educated idiot and say that my science is wrong unless you have an experiment that proves it wrong. And
that's right.
That's right. Understand.
It's just childish calling names. I mean, the bottom line is, we don't invent or discover new things in childish ways. So if you've got the information, present it.
Yeah, like call into my show. I said I challenged the guy to call into my show, and he's like, "Oh, I will." And well, we got 5 minutes left to the end of the hour, and I haven't heard from anyone. So
that's right. Hey, look, maybe in 20 years we'll have time travel, and you can watch YouTube, in 2 days, and then you can travel back to the beginning of the show, and you can do that. But we don't have that yet. So call in now if you're there. Okay, right. If you have a question, if you are,
if you think something I've said is wrong, if I made a mistake, call in and point it out. I'm not going to think, oh, I'm an idiot. Oh, yeah, everybody makes mistakes, and it's
You got
acknowledging
it.
your mistakes and wanting to correct things and getting correct information that I care more about than anyone's opinion on my credibility or who I am or what I believe in or
That's right.
my educational background or whatever their opinion is. I only care about getting correct information and learning what's right and
That's
what
right.
can stand up against the tests of science.
You got it. And,
So.
and and that's, honestly the way that we have to and we do approach it. Hopefully in everyday life, but definitely in the sciences, because the whole thing about research papers is that other people are going to be reading them. They're going to be performing the same tests or doing the same math, and if they don't come to your conclusion, they're going to come up to you and they're going to say, "I don't believe you. Your proof is an error. Your experiment doesn't work." And, I mean, you can't make any money in industry, let's say, if you give them a bad theory. It doesn't work that way. And that may not be your purpose, but inevitably, if you're wrong, someone's going to find that you're wrong. So let's not, put the ideas out there, show us what your facts are, or at least what your ideas are, and instead of just, again, hurling what I would consider childish comments. I don't mean to be offensive, but sort of the backyard school fight, fight on the court.
No, it isn't. Yes, it is. No, it isn't. No. Anyway, so, anyways, hey, this is what I do. It's this is my show. I'm trying to educate people and show them tools and other things out there. In the first part of the program, I talked a little bit about phasers, RLC circuits. I gave them a differential equation, which kind of almost looks like the equation for position, velocity, and acceleration, but in terms of current instead, where you have the capacitance, resistance, and inductance, all time variable terms, and
that's right. Mm-hmm.
And then if you and that's all providing you have like a sine function or some sort of alternating current function, like a putting into this, that you'll get actual real results out. You'll get resonances and other things out of that differential equation that you will pop out based on the values of that capacitance, the resistor, and the inductor. And that's how you build tunable circuits. That's how you build radios. You pick the right inductor and the right capacitor to tune into 104.1 megahertz, and then you have to have a high enough Q factor to basically pin in on that specific frequency so that you can eliminate everything else and only listen to that one, because otherwise your wire's listening to all the different frequencies. It's picking up every single electromagnetic wave that's hitting it. All those electromagnetic waves are going through your body, and the way to tune into them is through resonances and understanding the math and what these differential equations show and how they work. So anyways, that's sort of what I talked about.
And I want to remind people, once I said it before, but look, in the 1960s, there were kids. We're talking about 7-year-olds building these devices
I'm
in their garage and tense about it.
We have
so if they can do it, surely we can do it.
You can do it too. We're gonna wrap this up. We're at 5 o'clock in the hour. Thank you for watching the Alien Scientist Conspiracy Science Controversy Hour. Anything else you have to say before we go?
No, just get out there and experiment.
Yes, get your hands dirty.
That's right.
All right, thanks very much. Have a good one.
Okay.
Bye, Ken. Later.